Okay, so we got all the blocks ready to start milling in the profile of our part and ejector pins and the such. So what I have done right now is I've taken the time to put layout fluid on our parts and using a height gauge and the prints and notes that I have from the previous work, I make stack ups with adjustable parallels and 1, 2, 3 blocks to get the heights of every pin, and I scribe it on here. The lines that are vertical are where I'm going to be doing the trough for that T side stick that goes in there, and each one of these lines going this way are going to be for the ejector pin. So pretty straightforward and simple, just taking the time to make sure it's right before I bring it over to the mill. I'll drill all these holes out with an undersized drill for the reamer. Then I will drill the backside hole for the clearances, and then ream out the holes from the top to get what we want. Then I will do the profiles. So in a nutshell, that's what we got. I'll bring it back when we're set up in the mill. So, like I said, I got the block set up. We're going to do an edge finder of the two edges to locate our first hole. And then from the first hole, we will count how far we're going with the dials, spot, drill it, move down to the next dimension, adding to what we have on the dials, so forth and so on until we get halfway. Then we take it out, turn the block around, and we'll indicate again from the other side. And then the other edge. So it is a tedious process without a DRO, but it's what I have, so it's the way I have to do it. All right, as you saw, I did it actually a couple of times just to make sure that exactly at the point it's doing a kickover, and I actually had to adjust it back a thousandth of an inch to get it to where it just is at the point where it does a kickover. So now that that's done, our first dimension I've got on there is 0.782, 782 thousandths, but I have to add 100 thousandths to that. So now that my dial's at 0, where this is on the edge, I'm actually going to move it to 100. So when I go with the first 100, I'm at 0. And that puts the spindle directly over the edge. Now I'll do the 782 thousandths. So that's 2, 4, 6, 700. 50, 60, 70, 82 thousandths, and almost 73. All right, lock the table. So that puts us over the center line of our first hole in this direction. Now I need to bring the table over here and find the edge. Alright, so I set the dial at 100, I'll move to 0, puts me right on the edge, and the dimension I believe is 1 inch. One inch, 1/28. So 5 turns. 1, 2, 3, 4, 5. And that's 110, 25, 6, 7, 8. Almost there. Now I'll lock the other axis. Now that axis won't move until we get all the way done with the halfway of the holes. So if we bring it down, I just visually make sure it looks like it's on the mark. All right, like I said, we're going to spot drill, and ream. So I have the smallest spot drill I have. I'm just going to go in to get me a surface started so that the drill can find center. This is a number 44 drill, and this is a 3/32 reamer. So this is how I'll proceed with every hole going on down. So I'll spot it first and then we'll go from there. I will have to crank up the RPMs as far as they go. Alright, and I want to drill about 3/4 of an inch down. So I got my depth stop set for that. So, and I'll ream to the bottom of the hole, but I will slow it up. I'll put it in back here and add a little bit of oil to it. Is the first one done. Now I have a positive stop over here so that I can locate the next one, make sure I get it orientated the correct way. I can just slide it in. Do it again. Okay, so we have drilled all of the ejector pin holes. There are 7 in each block. So we got the 3/32 ejector pins, and then these are for the sprues that we'll be putting in later, the sprue ejectors. These are 3/16. So they've been drilled and reamed. They do go all the way through. These are all clearanced holes. They're bigger than the reamer. So there's only really about 3/4 of an inch of steel up here that is reamed to fit tight around the ejector pins. The rest of it is a clearance hole. So now my plan is to use the mill to mill out the channel that I've done with layout so that it'd be 5/8 wide, 3/16 of an inch deep. I'll do the bulk of it with a 5 flute carbide end mill. It's a 3/8 wide. So we'll clean this up, and then we'll use micrometers and adjustable parallels to get the width just right, you know, and then the length. So I'll take you over to the mill. We'll get that set up. All right, so I got it set up in the mill. I'm not going to indicate an edge. I got some scribe lines that I know I can go close to without going over, so then I can use a micrometer to measure the distance from the ends side so that I don't overshoot what I want. But I do want to get an accurate depth. So right now, this 5 flute end mill is not a center cutting end mill per se, but if I center over the hole, I should be able to drill down. If not, I'll step down as I'm cranking over the table and ramp it down. But I want to get a height set. So what I want to do is I'm going to use a piece of paper to gauge the height that I want to get to. So I can go up quite a bit, and then I start using the paper kind of like a feeler gauge till I start feeling drag on it. Then I know I'm about 4 to 5 thousandths above the surface. Okay, right about there. So I will set the vertical to 0, my z-axis on the knee, and I'm just going to call that 0, and I'm about 5 thousandths from hitting the bottom. And I can see where I actually rubbed off some of the layout fluid with the paper when it took up that distance. And carbide chips real easy, so you don't want to hit it against the steel, otherwise you'll ruin your cutting fluids. So right now my calculations say I need to be around 600 RPMs. So the closest speed I got is 660. So that's where I will be. We'll use coolant and we'll see what happens. Alright, so 3/16 needs to be 187 in depth. So I'm going to crank it up 100 right now, or I would do 50. So now that I'm there, I am going to set up a stop. So that as it's flooding with coolant, I don't overshoot it. Now I'm not going right to the line yet. I'm going to stay back a ways. And since both pieces are the same size, I can just swap in the next one when I get there. Alright, so now I got positive stops made. I'll turn the coolant on and I will go back to do another 50 thousandths. There we go. 3/16 deep, 3/8 wide. Now that I've got the slot just about to depth, I need to bring the table back at me, the y-axis, about 100 thousandths to clean it up. But I don't want to do a conventional cut, a climbing cut, so I'm going to go to this side to do a conventional. Once I get this over there, I'll come at me with the table about 100 thousandths and then run down. Alright, so I did a 50 thousandths coming back, getting this slot nice close to what it needs to be. I have about a thousandths, about 1 thousandths to take off of this side, which is good because I still have to run the tapered end mill there. And let's see what we got for inside. What I use is a adjustable parallel in there. Find this is a pretty good way of measuring it. So that's 540. So we got to at least take about 80 thousandths off, I think. We'll just run it again. We'll take 50 more and we'll go from there. Next side's up parallel. I need to loosen that up a little bit. So I'm about 590. After some time on the mill, I got both these blocks, well, roughed in, and then I did some finish work on this one, but let me just describe. So what I did is using that 1/2 inch 5 flute carbide end mill, I was able to rough this all out, again with coolant, and got it to size. The opening is actually about 2 thousandths smaller than what I want, and I have about 1 thousandths to take off on this side. So what I did is I got a smaller carbide end mill to knock out the radiuses here in the corner. Actually, this was a 3/8 radius. So I had a 3/16 radius here I needed to reduce a little bit. And that's what I did here. And I also, let me get the end mills that I was using. Hold on 1 second. All right, I got the end mills that I was using. So like I said, the first thing I did was I used the 3/8 end mill carbide to get this cut 3/16 of an inch deep. Then I used this other end mill, which is, I think it is 5/64 maybe, 4 flute carbide end mill. And I used this to reduce the amount of radius that was in the corner to get them even more manageable. Because the last thing you have to do on a mold is create draft or a taper on the sidewalls to help reduce the friction to pop the parts out when these ejector pins push the part out. And that looks like this. I've been buying these in a 3/32 diameter, which is the minor tip diameter, and a 3/4 inch length of cut, because some of the draft angles that I was trying to produce were quite deep. You know, I needed about 3/8 of an inch, and there was nothing in between in length, so the 3/4 was really what I found to work for me. But this long bit has significant amount of deflection that will happen as you're trying to route out these corners. I mean, it's meant for the lightest of cuts, really. And this one is actually very dull on the tip. It's been used quite a bit on this stuff. As you can see here, I hope you can see it in there. The draft angle that I needed to do took almost, a little over half of the amount of available cutter that I had. So if I was to do it again, I'd buy a much shorter one, more rigid, and probably carbide to work on these shorter draft angles. And then, so after I reduced the inside diameter of these inside corners with this bit, I used this to do a very light cut to take off about 1 thousandths of an inch all the way around to create a draft angle. And this is a 1 degree. This is a 1 degree 3/32 by 3/4 inch tapered end mill, and it is a 3 flute. So I've done the one block, and I have to do this next block, do the same thing. It just reading the dials. I've got stops on the X and Y, or the X axis, this direction. I have stops on the table, so it won't go farther than I need when I get to this. And then I have a 1 inch dial indicator set up on the table for the Y axis, so that I can always come back to the centers to get these as close to the same exact size as possible. And I verify all my dimensions. I've been verifying with an adjustable parallel. This one measures 5/8 of an inch on top. It doesn't go all the way to the bottom because of that taper. And that's fine. I need 5/8 of an inch or close to it up top, which is, pretty close to what I have. It will not, well, this one's bigger, so I may have to go back and adjust them to get them the same size, but the goal is to get 5/8 of an inch in here. So I just wanted to give you an update. I'll finish this block and bring you back. So here we are on the mill. As you can see, I have notes that I've drawn on here. These notes are my dial settings. So this one is the dial setting for this side of the X axis over here, so that when I move the cutter all the way over, I know exactly what number on the dial to stop at. And this is my dial indicator number for each direction. So this one is when I move the table this way, this one is when I move the table that way, and the last number was for that. I do also have positive stops set up down here. I was using that for this cutter. These numbers are represented for the 5/32 cutter that I was using to rough out these corners a little bit more. So now you can see, if you look, you can just slightly see the reds leaving on most of the top of this, so there's draft angle on it. Rest of it can be polished in and set up. So that is first step on getting these blocks roughed in or pocketed. Now I have to create another pocket down the center of these holes, another 1/8 inch deep and an 1/8 inch wide. So I'll bring you back when I get that set up.